So we're going to wrap up this unit, but probably not till the next lesson, because this is a pretty long one, this last one. Because we're going to take everything we've learned in the first 3 lessons and talk about, okay, now that we know how to divide by, or polynomials by binomials, now that we know how to use the remainder theorem, now that we know how to use the factor theorem, we're going to be able to graph these things now. And given the graph, we're going to be able to find their equation. But today we're just going to focus on how to graph these things. Okay? In order to graph polynomial functions, they have to be in factored form. Most of the time, you will be given the factored form, and you just graph from there. But sometimes you may have to factor, like this one. So we need to make this, by the way, how many binomials will this factor to? Oh, sorry, I don't have an extra. 3 of them. So it's going to be x and then some number, x then some number, x then some number. Right? So the first thing we got to do is we got to figure out what one of the factors is. How do I do that again? I need to find, or need to list factors of 6, and then try one of them, see if when I plug it into the function for x, it equals 0. So remember, plus minus 1, plus minus 2, plus minus 3, plus minus 6. I know it looks like a lot, but if we try 1 and -1 and 2 and -2, pretty much 100% chance we're going to find one. Okay? So let's try. What should we try? Let's try 2. Yeah. I'm going to cheat a little bit. I'm going to try one that's going to, I know it's going to work. So 2 to the 3rd minus 4 times 2 squared plus 2 plus 6. Well, that's the same as 8 minus 8, sorry, minus 16. Not 8. Minus 16 plus 2 plus 8, which equals 0. Therefore, what's one of the factors? X minus 2. How do I find the other factors? I take this and divide this by synthetic division and factor that answer. So 2 for A, list the coefficients, 1, -4, 1, and 6. I should definitely get 0 here, if I do it correctly. 1, 2, -2, -4, -3, -6, 0. I already know that if I divide by x minus 2, there's no remainder. What does this translate to? X. What's the answer here? X squared minus 2x minus 3, which I need to factor. X minus 3, x plus 1. So I found the 3 factors. Here, after doing the remainder theorem, here after synthetic division and factoring. So my 3 factors are x minus 2, x minus 3, x plus 1. Okay. What if instead of f of x, I put 0? And instead of x cubed minus 4x squared plus 2x plus 6, I wrote the factored form. So I turned it into an equation. Remember how to solve these when they're in factored form? Don't we have to find all the values of x that make this one 0, this one 0, and this one 0? What makes this 0? So that's a solution. Or remember, root means the same as solution. What's another solution? And -1. Okay. Not only is this solving an equation, but it's also finding the x-intercepts, because when you find the x-intercept of any function, don't you always make y equals 0? Or f of x equals 0? So what are the x-intercepts of the function? Well, it's the same thing. Bless you. What you do, remember we're writing factored form now, not the original polynomial. You just make y or f of x equals 0 and solve. Well, it's the same solutions. These two are the exact same thing. And you've already seen this word a couple of times. You should know what it means when you are asked about zeros. Zeros are the same thing as x-intercepts, the exact same thing. So if you are asked to find the zeros of a function, that's the same as the x-intercepts. So what's the relationship between if we solve it like an equation and if we find the x-intercepts? It's the same. How would you find the y-intercept? Make x equal 0. So, and I'm going to use the factored form again. 0 minus 2, 0 minus 3, 0 plus 1. What does that give you? -2 times -3 is times -1. Sorry, -2 times -3 times 1 is 6. Yes. Sorry, I was working reverse. I was thinking something else. So the y-intercept is 6. Well, guess what? We've got 4 points on what we're trying to graph. We know that it hits the x-axis at 2, 3, and -1. We know it hits the y-axis at 6. Okay? I'm not going to do sign diagrams. I'm going to do it a different way. Which, and some people will argue with me, I'm sure, which I think is more straightforward. Sign diagrams are useful. You use them in calculus, but in this case, I find that there might be a little bit of a easier way. So we're asked to graph, right? Well, what are the points we know? 2, 3, 4, 5, 6. We know the y-intercept is 6, so we know that's a point. We know 3 x-intercepts. 2, 3, and -1. Two, 3, -1. I know the shape of it. Like, what's the degree of this function? 3, and it's positive, right? So a positive x cubed function, doesn't it look like that? Now I need to fit this through these points. I need to take this shape and somehow draw it through all these points. Well, it's obviously going down here, and it's coming up here. So I'm looking at the ends. It has to go through this point, and then it has to climb up here. I know I'm not perfect here. It has to go through here. I don't know when it peaks out. I don't care. I just need to make sure it goes through here. Then it goes through here. And I don't know how low it goes, but it doesn't matter because we're only sketching. So I turn it back up and connect it. And it's going to look like that. I find that's a little easier than the sign diagram. As long as you remember what an x cubed looks like, what an x to the 4th looks like, and what an x to the 5th looks like. An x to the 4th looks like that. An x to the 5th has got, it's like a double x cubed almost. And then if they're all negative, you have to flip all those upside down. So that's how you graph. Okay. You need to find the x-intercepts. You need to find the y-intercept. You need to take the shape of the graph that you know it's going to be, and you need to fit it through those points. But sometimes we may run into a problem. Not a problem, a situation. Okay. In the previous example, and in this example, my curve went through all the x-intercepts, didn't they? They just went straight through them. What we call that is multiplicity of a 0. And remember, 0 means the same thing as x-intercept. So the multiplicity of a 0 is how many times it occurs in a function. And it's going to be 1, 2, or 3, depending on whether it goes straight through, whether it bounces back, or whether it flattens out. So all of these, this 0, and this 0, are all multiplicity 1, because they just go straight through. Like this goes straight through, this goes straight through, this goes straight through. But notice in the second one, this doesn't go straight through, does it? It bounces back at -2. Like this is still a 0. It hits it, but it bounces back. It doesn't go straight through. When it bounces back like that, we call it a 0 of multiplicity 2. This one's still multiplicity 1. Because it goes straight through the 0 or the x-intercept. But this one is multiplicity 2. This one, notice it goes through, but kind of in a weird way. Like it's going up, it's heading towards this, it's heading towards it, but then it kind of flattens out and runs along it before it continues through. When it flattens out like that, that's multiplicity 3. We don't see that very much. So if you've got a 0 of multiplicity 2, that means it's going to happen twice when it's in factored form. So for example, and again, we're not going to do the sign diagram. And we're not going to do this. Notice the x-intercepts here, or the zeros, are -2, -2 again, and 1. That's what we call a repeated root or a repeated solution. It happened twice. I mean, normally we don't write them twice. Okay? When it happens twice like this on the graph, it's going to bounce back. So whenever you see a factor that happens twice, or an x-intercept that happens twice on the graph, it's going to bounce back. And it could bounce down if it's going up, or it could bounce like that, depending on the graph. Okay? So it bounces back down. So if we get a 0 twice, just remember it's going to bounce on the graph. Okay. This one. Again, don't worry about the sign diagram. Notice this one, you're given the factored form, which is nice because that would take a long time to factor. Okay. So the x-intercepts, or the zeros, and keep using those interchangeably until you know that. All the values of x that make this whole thing 0. What value of x makes this 0? 0. What value of x makes this 0? 1. This one? -2. And 3. Okay? But remember, this one has multiplicity 2. How do I know that? Because there's 2 of them squared. So that means when I graph it, it's going to bounce back at 1. So we've already got 4 points on our graph. I know that it's going to go through 0, 1, -2, and 3. I need another point that it goes through as well, the y-intercept. So how do I find the y-intercept? I gotta go -0 times 0 minus 1 squared times 0 plus 2 times 0 minus 3. Well, 0 minus 1 all squared is +1. This is 2. This is -3, and -0 is just 0. So what's 0 times 1 times 2 times -3? 0. So the y-intercept is 0. So that means not only is this the x-intercept, it's the y-intercept. So I didn't find an extra point. What's the problem? Yes. So -0 times 1 times 2 times -3. As soon as I have a times 0 in there, it's 0. Yeah. I have what? Oh, sorry, I have 4. Thank you. Okay. What does a -x to the 5th graph looks like? This is where you got to be sort of on your creative side. Like, this is what a positive x to the 5th looks like. Negative, you got to flip it. So it's going to look like this. So I've got to take this. And have it run through those 4 points. Here's how I do it. Like, first of all, I look at the ends. I know that on the left side, it has to go up like this. I know that on the right side, it has to go up like, or down like that. I know that at 1, it has to bounce back. So these ones are multiplicity 1. They go straight through. So I go straight through. Now I got to curve back down and head towards this one, right? Do I go through it or do I bounce back? I bounce back, so I got to go up. I shouldn't have gone up so high because I got to turn around and go through that one, right? So I got to do this. And then it curves like that, and I finish it like so. It takes a little bit to get used to. Okay, and again, I don't know how low this goes. You could have done it like that, and it's still right. Okay, you could have shot this one up higher, and it's still right. Because remember, we're only sketching it. Okay. So I'm going to stop there. And we're going to go the other way on Friday, where we're given the graph and asked to write the equation. Okay.